Welcome to CS1104 Computer Systems. This is the Unit 2 lecture part 1. During this lecture, we're going to cover the fundamentals of Boolean arithmetic. Now, you might be wondering, why is that important? Well, we just talked in the previous unit all about this notion of gates and circuits and the fact that I can actually control electricity by turning things on and off with transistors. Well, when I'm able to turn things on and off means I have basically two values, 0 and 1, or the binary number system. Now, if I had a way of manipulating or doing mathematics using only binary system, then I can actually start to implement that using these transistor gates. And essentially what we're going to look at is the way that we can actually do arithmetic with binary numbers. Now, there are two basic functions that we're going to look at doing, and one of them is binary addition. Now, keep in mind that in binary, basically what it means is that unlike base 10, which is the decimal system, deci meaning 10, I actually have 0 through 9. So 0 through 9 meaning I have 10 different numerals that are part of the numbering system. In binary I only have 2. I only have 0 and 1. So just like in the decimal system, if I were to add two numbers together and it becomes larger than 9, that means I have to move to the place to the left. And I'm doing the same thing. We call that a carry. So we see some examples of binary addition here. If I add 0 plus 0, it's 0, which means I don't have to do anything. 0 plus 1 is 1. I don't have a carry. 1 plus 0 is still 1. I don't have a carry. But what I wind up having to do is that if I add two numbers together, 1 plus 1 it equals 2, but I don't have the numeral 2. So what I have to do is I have to carry it to the next place over. And that next place over basically means 2. So binary addition, relatively simple. And this gives us a little bit of an example of adding binary numbers, and just what we've gone through. I'm adding zeros together. It doesn't have anything. When I add 0 plus 1, I wind up having 1. Again, I'm not carrying anything, which is why I have a 0 up here. Now, when I add 1 and 1 together in this particular column, we see that I have 2, and I can't use 2 because I only have 0 and 1 as numerals. So essentially, I have to carry that to the next column. So you see that I've carried the 1 over here. And then I add 1, 0 and 1 again here, and then I have to add the carry to it, which means again I'm at 2. I can't have a 2, so I have to move it to the next place. So this gives you a sense of how we're carrying it along and when we do addition of binary numbers. Now, the big problem we're going to run into is how do we do subtraction? And the way that we do subtraction is a little bit unique. Essentially what I have to do is I have to convert the binary number into something called 2's complement. And when I've done that, then I can actually just add them together. So doing subtraction in binary, or in a binary number system, to do subtraction, the way that I can do that is that I convert one of the numbers into 2's complement form, add them together, and voila, I wind up getting subtraction. Now, how do I get to 2's complement? Well, we're going to look at that real quick. The first step in doing 2's complement is that I have to get into 1's complement. And the way that I get into 1's complement is I take the binary number. So, for example, this is the binary number that I'm dealing with. I want to invert the bits. Now, when I say invert the bits, it means essentially everywhere I see a 1, I want to make it a 0. And anywhere I see a 0, such as this particular case, I want to make it a 1. Pretty simple. So 1 0 0 0 1 1 becomes 0 1 1 1 0 0. Once we've completed that step, we're going to make it into a 2's complement. Very, very simple. So once I have all of the bits inverted, so for example, I'm starting with this number. In this particular example, here is my 1's complement. You notice that I've inverted all of the digits. So wherever I have a 0, I made it a 1. Wherever I want, I made it into a 0. And then I just add 1 to it. Voila, I now have a 2's complement number. And like I said before, if I wanted to subtract this number from another binary number, all I need to do at this point in time is add them together, which is what we're seeing here. We're going to add them together. And I wind up having a couple of different cases. So let's say that I'm adding, I want to subtract one number here from another number. And essentially I just add them together and I wind up getting a result. By the way, this leftmost bit, the leftmost digit that we wind up having is important, because what it tells us is it tells us the sign of the entire answer. So basically, when I'm done with it, the number that I'm dealing with is really right here. This is actually my result. And so if I add 9 to minus 5, essentially it's telling me that the result is 4. So 2 to the third position here, it's basically 4. However, I've got this carry bit over here, and what this carry bit tells me, when it's a 1, it means that the number that I have is positive, and if it's a 0, it means that the number is negative. So I know that my result is 4, and that 4 is actually a positive number. I can actually have a different scenario. So here I'm subtracting, or actually I'm adding a minus 9 to 5, and as we all know, my result should be a minus 4. So I'm seeing the same kind of a thing here, where we have that result. However, since I have a 0 up here, I know that my result is now, in fact, a negative number. And the final example or case that we might run into is how do I subtract a negative number? So if we think about it, it's really no different, because essentially when I'm subtracting a negative number, it means that I'm simply adding a number to a negative number, which means it's the same case as we've seen before. So same basic thing. We can look at the different cases, but I can subtract two negative numbers from each other. I can subtract a negative number from a positive number, or I can, subtract two positive numbers.